Hello, everyone. Good evening to all those who are from India who have joined us for this today's session. So, this Rohit. I am from Confab Technologies, and we are pretty excited to host you all for today's meetup on building serverless applications using AI services. So, for today's meetup, we have great speaker Suman Devnath. He's from AWS. So, before we get started with the session, let's bring Suman on board, and he'll be giving you the introduction about what this session is going to be about today, and then we'll get started.
Sure.
Yes.
Thanks so much, Rohit. Hello, everyone. Welcome to this session. And today we are going to talk about how you can make use of serverless into your machine learning framework. So basically, we will try to host some machine learning models on the web using serverless. So this is what we are going to talk about today.
All right. So, Suman, you can share your screen, or we can.
Yeah, sure. I'll do that.
All right.
So I hope the screen is visible now.
Yes, Suman. It's
Okay.
live.
Perfect.
All right. Over to you, Suman.
Sure. Thank you so much. So, all right. So, at any point in time, if you feel that the voice is not coming or something like that, just ping in the chat. I'm not able to see the chat, but maybe Rohit and Karthik can help me by alarming me about this. Okay. So, what we are going to talk about today. So we are going to talk about AI services. How you can host AI services on serverless. So it would be more around Lambda and how you can make use of a serverless framework altogether. Okay, so the idea is not about machine learning. I know that you all are machine learning experts, and you know better than me about how to train, build, and deploy models. We are just going to look into one of the area where you can leverage as far as the machine learning hosting is concerned. Okay, so I don't have. I have some slides, but I really don't want to bore you with those slides. So that's the second slide. So I do have some backup slides, which I can share it with you if you feel like, which will cover a few of the things that we are going to discuss today. Okay, so feel free to ask questions. And if you're new to serverless, feel free to ask questions. And also, you can ping in the message if you are new to serverless, so that we can discuss something around Lambda. But the focus is more around hands-on things, so that you get a feel of how things work. Okay, so that's what we are going to spend next 30-40 minutes. Okay, so with that, I'll just come out of this presentation mode. And again, we have lots of slides, but those are really to build an intuition of how serverless works or what is serverless. But if you feel like that you want to have that discussion, then I can show it to you. Okay, but let's get the ball rolling, and let's straight away go to the main agenda of the day. Okay, so before we start, a quick overview of what serverless is, right? So if you look at it, the way that we can define serverless is like this. So let's say um, when you host any application, you take a server, right? And you build your application here. Right now, this application is always up and running in your server. Now, someone from somewhere from the internet or your client. So these are nothing but your clients, right? So they try to access your application. So it may be we are talking about a web application. So they might try to access using some API, right? Maybe HTTP, REST, whatever it is. Now imagine that this application is having some database or storage and so on and so forth. So all of these you will be charged always, right? No matter this guy, no matter this guy is using your API or not. Let's say at night 12 o'clock. no one is going to access your website, but still you have to pay the bill, right? So this is where serverless comes into picture, where whenever you have an application which is kind of an trigger based. By meaning by What do we mean by trigger based? Let's say you run a company. So now let's say you run a company where this is your application, right? And let's say the app, what this application does is it converts let's say PDF to, let's say, doc. So this is the only thing that your application does. Okay, so now in spite of keeping this in a physical server, what you can do is you can deploy this in a serverless fashion. And what that means is the whole application, right? This whole application will now in terms of AWS, you can deploy this application as a function. Okay, and we call it as a Lambda function, right? And what it does is, now whenever a user uploads a PDF, right, this application will automatically trigger. Okay, so the moment you send a PDF document to some place, so let's say that might be an S3 bucket, right? So that might be an S3 bucket. The moment it gets uploaded in this S3 bucket, this Lambda function will be triggered. Okay, this will be triggered. Okay, and now once it is triggered, what it will do is it will take that PDF, it will convert into doc, and once that conversion is over, it will again save it in some S3 bucket, right? Just like it got triggered by some S3 bucket. After this conversion, this document file will be saved in this S3 bucket, right? And then it can notify the user. In fact, user can get the notification right after the image got uploaded in the S3 bucket, and it can get a response. Okay, or it can also you can build your Lambda function in such a way that the response comes after this conversion is over. Okay, but this, as you can see, this whole process might take some time, right? To upload, to run this Lambda function, and to save it in this S3 bucket, it might take some time. So this may not be a right way. In this case, this is a synchronous call, right? Because you are uploading something and you are waiting for the whole activity, task 1, task 2, and task 3 to complete till it gets the acknowledgement, right? So that's why this is not what you would like to do, but you may like to just get the response asynchronously, right? And then at later point in time, you can go to this website, go to this S3 bucket and collect the result. Now the benefit of serverless is this part, right? This this black part, because the moment this task is over, let's say this task took, let's say, 10 seconds, just hypothetically saying, to convert a PDF to a doc, you will be charged only for this 10 seconds. Okay, so after that, this whole infrastructure will be destroyed. This won't be there. Okay, this whole infrastructure will be destroyed. Ideally, in a more technical words, it will not be destroyed immediately, but it will destroy. It will get destroyed after some time. So let's say the first invocation, right? The first invocation you did now, right? The first invocation you did now. So now it will download the code that you have, like this code, right? This whole code, and we are going to see that in action in some time. It will download the code, it will process it, and it will at the end it will save the result, right? Now, while it is doing all of this, let's say another invocation come from your customer, right? So let's say this is the second invocation, and this second invocation came while this was running. Okay, while this whole thing was processing. So in that case, it will again start another instance of that. Okay, but let's say the third invocation came after a long time. Okay, so in that case, it might happen that after this first invocation, right, which got over by this time, right, this will not get destroyed. Okay, this will not get destroyed, but it will be there for some time. We don't know how much time, but it will be there for some time. And why it is there? Because we feel that it might happen that there might be another invocation might be coming. In that case, I don't have to do all this preloading of the code and all of that, right? Because it's already preloaded, the infrastructure is already there in the AWS. I can just run the code, right? And this is what we call it as a warm start, right? So the idea is, in serverless, you don't have to worry about the scale. You don't have to worry about the infrastructure. Okay, so that means all this infrastructure that that we discussed, right? All this infrastructure, it is all maintained by or managed by AWS, right? And the moment an invocation happens, it will create a container. So this is the container where your operation is running. This is the whole code which is running. It's actually running in a Docker container, right? And you don't have to manage. So AWS will take care of all the infrastructure for you, right? So that you can focus on your core business, right? And your core business is this, right? Your application. Okay, so that's the whole idea of serverless. Now, I just want to give you some intuition of serverless, so that now if we go back to our main topic of the day, where you can use machine learning models for server and deploy it in a serverless fashion. Okay, so before we do that, let me just go back to this and tell you now what we are going to do. So now what we are going to do is we are going to build a serverless application. Okay, so now this is our application, right? This is our application. And what we are going to do is we are going to, so the problem statement is, so let's first write the problem statement. The problem statement is, given a text, okay? So given a text, we have to find the sentiment of the text, or let's say what are the entities there in that text, like whether that text contains a name or an organization name or date or so on and so forth, right? So basically this is an NLP task. Okay, this is an NLP task. Okay, it's a natural language processing task where the user will give you some text. Okay, and what we have to do is we have to comprehend. Okay, we have to comprehend that whole text, and we need to provide output as what is the sentiment of that. What is the sentiment of that text? So this text might be, let's say, Amazon customer reviews, right? Let's say in Amazon.com or Amazon.in, we have lots of customer feedbacks, right, for all the products. Let's say we need to analyze what is the sentiment of all those comments, right? So this is what we are going to do. Now, we are going to do this in a serverless fashion. So what we are going to do is we are not going to train and build a model. Okay, so we are going to use the Amazon comprehend function. Okay, Amazon comprehend. So this is the there is an AI-based service that we have called comprehend, and we are going to see that now. But and it's simply an API-based service. So whenever you send a text and call comprehend API function, it will just return the sentiment and whatever you feel like entities and so on and so forth. And we are going to see that. And the way it will work is like this. We will create a Lambda function. Okay, this is our Lambda function. And this Lambda function will be triggered because the way that you can look at it, a Lambda function is it should be a trigger based. So although it can work without trigger as well, but in general, almost most of the time, you will find Lambda are used in an application which is architected as a trigger based architecture. Right? Okay, and the trigger means this application should be invoked by someone. Okay, and in our case, that someone would be S3. Okay, so what we are going to do, we are going to create some text file. Okay, we are going to have some text file, and we are going to upload that in an S3 bucket. And the moment this Lambda function realize that there is an upload in this bucket, this Lambda function will be triggered. Okay, and once this is triggered, it will call the comprehend API. So it will call the Amazon Comprehend API, and it will send this text, and it will analyze, and it will get the sentiment, and it will be printed. In this case, I'm not saving that file, saving the result, but it will be printed in the logs. It will be printed in the logs. So I just wanted to focus on this part, only on this part, like how you upload the text and how you call this Lambda function, right? Because once you get the result, you can do whatever you want, right? You can integrate it in your application code or whatever you want to do. So we are just putting it in the log so that you get an intuition of it. But idea is, once you are done with this function, you can do you can use that result as and when you need it. Okay, so let's go and try this function. Okay, so what we have to do is first we have to log into our console. So I've already logged into the AWS console, and you can search for Lambda. Okay, so this is the first dashboard that you would see. You might see a different dashboard if you have never created any Lambda function. That would be a welcome screen, but nevertheless you will come to this page. Okay, when you click on dashboard, I have already have a couple of functions here, and if you click on functions on the left hand side, you will see all these functions. Okay, so what we are going to do is we are going to create a Lambda function. And we can name this function as, let's say, my comprehend. Okay, and it is going to be a Python application. So since AWS is going to create the Lambda function, all right. So AWS is going to create the infrastructure to run your Lambda function. You need to provide what should be the runtime. Okay, and in the back end, what AWS will do is it will create a container of a similar runtime. Okay, with the Python runtime, and then you can just simply create the function. Okay, so let's wait for this. Okay, while this is happening, I'll just copy the code from here. I'll just save it in my clipboard, and I'll walk you through the code. Okay, so now that Lambda function got created, if you see here, we got a function overview where we see that Lambda function here, but we have not yet added in trigger, right? And if you scroll down, you can see a editor where you already got a Lambda function.py, right? And nothing is there. So this is just I'll just increase the font a little bit so that you can see. So this is just a dummy function, and I'll walk you through the code that we are going to use now. But this is the place where you have to write your own Lambda function. Okay, so just to summarize, this is the place that we are in now. Okay, this is the place. Okay, this is the place we are in now. All right. So now what we have to do is we have to first, we can either write our code first place, or we can add the trigger. So let's add the trigger first. So when you click on add trigger, you will see a lot of different services. Like you will see API gateway, IoT device, CloudWatch, DynamoDB. That means your Lambda function might get triggered when there is an entry in a DynamoDB database. So DynamoDB is a NoSQL database from AWS. So you can imagine that where else you can fit a Lambda function. So let's search for S3, because we know that we are going to have this Lambda function triggered when there is an upload of file in an S3 bucket. So now you have to define tell which S3 bucket. So I have created an S3 bucket for this, which is this one, AWS ML hack NIT demo. And then you can also specify at what type of event this Lambda function should be triggered. So if you if you click on this drop down, you can see a put method call, or a post call, or a copy, whatever it is. Okay, so let's go with the default one, like all object creation. That means whenever there is an object upload in that S3 bucket, just run this code. Now you can also filter out only when a text file is uploaded, then only you should trigger this. Okay, you can always tell that, but let's keep it simple, because we are not going to upload an image, right? Otherwise our code will break, right? But if you want to have a very good error handling, you may say that I want only dot text file. Whenever there is a dot text file uploaded in S3 bucket, then only this code should be triggered. Okay, so this is the thing that you can do. Also, you can also provide some prefix, so that in your S3 bucket, you can have multiple folders, and you want this Lambda function to be triggered only when there is an upload in a particular folder. Okay, so that's about it. So let's leave everything as it is, and acknowledge this, and let's add. Okay, so now we have this S3 bucket. Okay, so now we are going to write the code. So if you come down to code, and here we can paste the code that I've copied. Okay, so let's walk through this code. It's a very, very simple code, nothing much fancy. So we are going to use JSON and Boto3. So Boto3 is the SDK to access any AWS resources in AWS. So we are just using that. And what you're doing is you are creating a S3 client object. And then one important thing to note here is this Lambda function, which I missed to tell you, and that is there in the presentation. So Lambda function would be always contain an event and a context. Okay, and you can name this function anything else, that is also fine, but you should always have event and context. And what this event does is, event will have all the information about the trigger. Okay, that means like in this case, the trigger is S3, right? S3 bucket of any object in the S3 bucket. So it will contain everything, like details about the S3 bucket location, name of the file, or the name of the object, and so on and so forth. Okay, and context will have some metadata about that inference. Okay, so you can for now, most of the time you will not need this unless until you do some metadata operation, but most of the time you will be working on this event object. Okay, so when this code triggers, okay, when it starts to execute this function, it will capture all the information about the object which triggered this Lambda function in this event object. Okay, so the first thing that we are going to do is we are creating an S3 client. Okay, because we are going to read and read data from that S3 bucket, right? And we are saying if event, that means if it is true. I mean, you can actually make a more sophisticated code, but just to walk you through the flow of it. Okay, so that means whenever there is an event, then this is the bucket name that we have mentioned, right? So I'm just putting it in a bucket variable, and now I'm reading the file object, okay, which is there in the S3, which actually got uploaded. So I'm reading it from the event, and in that event there is a field called a record, and then inside that the first element should contain the object name. Okay, so this is the place where I will get all the details about the object. Okay, and how I know this this whole hash, I do not know actually. So what I did was, the first place when I started to write this, I just did a print event. Okay, and it got printed in the console, and I then uploaded the file in S3, and I could see that how this event object looks like. Okay, it's a JSON, it's a dictionary basically, and from there I know that which part of that contains the details about the file that got uploaded. Okay, so that's how I came to know about this. Now the first thing that we need to find out is the file name, right? That is nothing but the key of the object. Okay, so in S3, if you're new to S3, if you're new to S3, in S3 you have something called bucket, which you can think of it as a folder, which is not the case, but hypothetically you can think of it as a placeholder. Okay, and it is uniquely global across the globe. Okay, so if you create a bucket with a name like, let's say, Amit, you may not find that bucket because Amit is a common name. Someone must be using that. Okay, and we are going to see S3 in some time, but basically you can think of it as just like Dropbox, right? How you upload data in some place, and many other services that we have available. But S3 is within AWS, and it gets nicely glued across many other services, and it is scalable, highly durable. And when you create a bucket, after that you can dump data in that. So you can create some folders and all of that, and then actually upload your files. So to know the actual file, you need to have the whole path of that file, right? And that is what the key is. And to get the key, we are calling s3.get object, and we are providing the bucket name and the file name. Okay, so now we have this file object, and now what we have to do is we have to now read that file, right? So that is what we are doing with the read method. So now I'm just reading the whole text file, because I'm assuming that the file, if you look at it till now, I have not checked that whether the file is a text file or not, right? Because I'm assuming that the file should be text, in the form of text. So you can add those check-ins in the code, or you can restrict it in the trigger itself, as we have seen some time back, right? So once that is done, then you call comprehend. So before that, again, you have to create a client object, just like before you have created a client object for S3. Right now we are going to call comprehend, right? So we will be calling creating a client object for comprehend, and then what we are going to do is we are going to say comprehend.detect sentiment. That's all. Okay, so we are not training a model, we are not testing a model. All we are doing is just an inference, right? And that's how you can integrate AI intelligence in your application without being a data scientist. Okay, so you being a data scientist or machine learning engineer, you may like to train a model of your own, and we are going to see that after this demo. But here we are assuming that we are going to use a managed service from AWS, and in this case it is comprehend, but you can use many other AI based services that we have, like recognition, translate, etc., etc. Okay, based on your task. And then you call this method detect sentiment, and you pass this text which you have just saved, right? Which you have just stored in this body string object, right, in line 29. And then you get the sentiment response, and this is what we are going to print in the log. Okay, and similarly, comprehend has several different methods. One is detect sentiment, then another is detect entities. Like it will detect whether the text contains any entity or not, like name, organization, date, so on and so forth. Also, it can detect key phrases, so that also you can call. And at the end, we are just returning this response. So this is just a dummy response. In our case, our task gets over in this line itself, right? Because all these 3 lines is what we need. Now imagine that if you are going to write your own application, and you want to make use of serverless, and you want to make use of AI capability, then this is the way that you can make use of it. Okay, so let's try this out. We have written our code, so let's go ahead and save it. Sorry, let's go ahead and save this Lambda function, and let's deploy it. Okay, so we have deployed that now function. So now we can just put a file in our S3 bucket and see whether this gets triggered or not. So for that, we need to go to S3, and we need to go to the exact bucket which we have selected, and that is this bucket, right? So there is no file, so let's upload some file. So I have some file called sample.txt. Let me just upload it here. So looks like it got uploaded, and now let's go to our Lambda function and come to monitoring, and we can open the CloudWatch log. Okay, so CloudWatch is our logging, the service where we store all the logs for any of the invocation, not only for Lambda, for all the other services. And here you can see what is happening, what is what is not working, what is working, and so on and so forth. So now it seems that it did not work, And let's see what it complains. It says that an error occurred called access denied when calling the get object operation, access denied. Okay, and this happened in line number 25. So let's go back to our code and let's see what we have in line number 25. So in line number 25, it is trying to access the S3 bucket, right? And this is giving us an exception that it doesn't have access, which is true, right? Because for us, in AWS, security is the main thing, right? And here, if you see, what I'm trying to do is after creating this Lambda function, right? I'm trying to access this S3 bucket, but I don't have access to this, right? Similarly, I should have access to this comprehend function as well, which I'm going to call later on, right? This also I have not provided access. So when you create a Lambda function, there is it gets only a basic permission to write logs into CloudWatch. That's all. That's a basic execution permission that a Lambda function gets. So after that, you have to add permission as and when needed. So for this case, you need a permission to call comprehend, and you need a permission to read data from S3. So let's go ahead and do that. So to do this, let's come to configuration and come to permission. And then you see that there is an execution role, which is already attached. And this got created automatically when we created this Lambda function through the UI. Okay. So what we are going to do is we can either edit here, or we can click on this and it will open up in a new console. And here, if you see, this is the policy it has attached, okay, basic execution role. And if you expand this, you will find that it has only CloudWatch access, right? So now we are going to add some policies. And first is S3. So we can give S3 read-only access, right? Although you can give full access, but let's restrict that. And also, we need to attach comprehend, right? So we can give comprehend full access, okay? So, and let's attach it. So now this has all the three permission. One is to write in the CloudWatch, which was there by default, and one is to read data from S3, and another one is to call comprehend, right? So now it looks good. So now what we can do is we can close this CloudWatch windows, and now we can go to our S3 bucket, right? And we can upload the data, right? Let's upload the data again. Although it's the same file, but it will get uploaded because it's a new version. It will assume that it's a new version, so it will get uploaded. So now let's go back to comprehend and Lambda function. And now let's go to monitor and open the CloudWatch log and see whether now it is working or not. Okay, so now if you see here, it could able to read the sentiment, right? If you see, the sentiment is positive, right? With a confidence score of around 77%, right? And also if you scroll down, it also predicted the entities. So if you expand this, you will find that there is an text called AWS. So if you look at, I did not show you the text file. So let's open this text file, and it is very small. Okay, so if you see this, it says that I'm studying machine learning with AWS. I'm from India. Okay, so this is just a random text. And now if you look at it, we have AWS here, we have India here, right? So if you look here, it has already detected that there is a text called AWS, which is, it has tagged as organization. Similarly, it has tagged India as the location, right? So basically, this is how you can make use of Lambda function to trigger any of the any of the AI-based AI-based services within your application. Okay, so that's the first thing that I wanted to show you. So this code is nothing fancy, but all I wanted to show you is how you can make use of Lambda to trigger any inference. Okay, so in this case, the inference was a Comprehend API service, right? This line number 35. Okay, 35, then 39, and 43. So this is an AI based service that we have. Now imagine you have trained a model maybe on SageMaker or on your local machine or wherever it is, right? And now you want to make that trigger. So you can always do that using Lambda function, and that is what I'm going to show you next. So let me just close this. Okay, so now, so all this code is available to you. I mean, after this session, I'll share you the GitHub repo. This is a GitHub repo, and we will have three different demos. One is the component which we have just done, and I'm going to show you this one, local. And EFS one, this is an exercise. You can try it out, and you can ping me later on what you have learned there and why EFS makes more sense. So EFS is Elastic File System, and I'm going to tell you a little bit about that towards the end. Okay, but now we are going to look into this application. So let's go to this Cloud9 instance. So I'm just doing the writing this code in a Cloud9 instance. If you're new to Cloud9 instance, Cloud9 is a service that we have where you can get a fully blown IDE on the cloud. So you can write your code, you can deploy your Lambda functions, etc., etc. It's just like a virtual machine, but with a nice fancy IDE on the web. Okay, so I don't have to carry my laptop. If you happen to invite me someday in your home, I can come and I can log into my AWS console, and I can show you all the things that I have been working on. Okay. So so basically, this is on the cloud. I don't have any dependency to carry my laptop. Okay, so if you look at this this folder, right, there is something called PyTorch app.local, and the way that I've created this Lambda function is not through UI. Okay, I've created this Lambda function using a tool called SAM. So SAM is a tool for serverless. It's basically a framework which can be used to deploy your serverless-based application. Okay, so we can discuss about SAM some other day. But basically, what you do is you do SAM init. This is the first step that you do, and you can give some name. Okay, so you can say that I want to start with a template, and let's say I want to go with an zip folder or an image. And why this is coming? If you go here and create a Lambda function, there are different options that you get, right? All of these three options, author from scratch, blueprint, and browse serverless application repository, all these three are actually creates a container for you on AWS, right? And this is what this option is, okay, where it just takes the code from you, and AWS creates a container, right container for you based on the runtime that you mentioned. And there is another thing called image, and this image is about this functionality, where this is recently added capability in Lambda, I guess last year, where you can actually give the whole container itself, and your code should be there inside that container. So everything would be there. Everything would be managed by you. Managed by you in the sense everything will be provided by you. Okay, so you don't want AWS to build your container. You want more control for your code where it is running. So you can just define your container. Okay, so when you use SAM, you can define whether you want a zip or an image. So let's say image, and then you can define what should be the runtime. So let's say Python 3.8. So you can select 4, and then you can give some name. So let's say foo. Okay, this is just a project name. And the moment you do that, it will give you some quick start templates. So let's say I go with the first one, hello world. And the moment you do this, you will find in the left-hand side, there is a folder called foo got created, right? And inside this, you will have a lot of different files. You will have a folder called Hello World because you have selected this Hello World example. That's why this folder name called came as Hello World. And then here you will have this app.py. And this app.py is nothing but that Lambda function, which we saw in the UI. And since I have selected an image type, that's why we already have a Docker file. Okay, and the last thing that we have we get is we get a template, and this is the template or called SAM template, which contains all the different constructs that is needed to deploy your Lambda function. Okay, like let's say you want to create a database, you can define that. And I'm going to show you that template in a while so that you get a better understanding of this. So basically, once you do SAM init, you get all of this preloaded, and then you can just edit these files wherever you want. And at the end, what you have to do is you have to run you have to go to that folder foo, and then you have to run SAM build. Okay, the moment you do that, it will build based on the SAM template and based on the container details that you have mentioned, or the container image details that you have mentioned in the Docker file, and it will build that locally. Okay, and once that is done, the last thing that you have to do is you have to say SAM deploy. That's all. Okay, so SAM will take care of everything that we have done in the last example manually, like creating an S3 bucket, or redirecting it to the S3 bucket, and managing the IAM policy. Everything will be managed by SAM. Okay, so now let's quickly look into this application. Okay, so I'm not going to use this foo. This is just to show you what are the three things that is needed. That is SAM init, then SAM build, and then SAM deploy. Okay, if you want to know more about SAM, we can have another session and some other day. And in my presentation, which I have, it contains everything about SAM to get started. If you're new, if you want to explore, you can refer to that. But for now, you can just think of SAM as a deployment, as a framework to deploy your serverless application. Okay, so similarly, I have done this beforehand, right, in PyTorch app.local. This is one of the application I've built, and in this application, what we are going to do is we are going to have a problem of question answer. This is using BERT, and if you know BERT, it's one of the advanced model that we have in the recent past on NLP. So we are going to take a pre-trained model from BERT. Okay, and we are going to use that for question answer task. Like, the problem is user will provide a question and a paragraph. Okay, and now the model need to predict whether what is the answer of that question given that context or given that paragraph of text. Okay, this is a very famous problem of question and answer. You can read about it in the BERT or Hugging Face libraries website, or anywhere. There are tons of articles there, but this is a problem statement. Okay, so now imagine you have trained a model using SageMaker to solve this problem, or you have trained this model in in your laptop or in your server, out, not on cloud, whatever it is. But after the training, you have your artifacts, right? So you have the model data. So now you want to deploy an Lambda function for inference. Okay, and that's what we are going to do now. So since we are going to use a Docker container, we are saying what type of what is the base image of the container that we should have. Then there is a requirement.text, and since it's a PyTorch, the code would be in PyTorch. So in the requirement, we have mentioned this is a torch, and this is the version you can mention. It's just a regular, standard thing, and then we are saying that copy to this app.py. Okay, this is the Lambda function, right? And we are going to go over the Lambda function in a while. But after this, what we are doing is we are creating a folder and we are copying the model. Now, this is the custom model that you may have in your environment, right? Whether you train it from SageMaker or it can be in S3, wherever it is. But in this case, I'm directly copying it from the internet and I'm saving it inside this model folder. Okay, So I have this PyTorch model.binary file, the config file, the tokenizer, and so on and so forth. Okay, so these are the 4 files that I need for let's say for inference. And all I'm doing is I'm first creating that folder, and I'm copying all these files inside that folder. Okay, that's all I'm doing. So my container is now having all the model artifacts, right? And at the end, what I'm doing is I am going to start this application, right? So in a Docker container, you need to start that application, right? So this is what my application is: app.lambda handler. So inside this app.py, if I double click now, you'll find this lambda underscore handler. Okay. So in this code, so this is the code for the Lambda function. And it's very simple. I'm going to use transformer for this, and that's why we have kept that in the requirement.text. And we are loading the model and the tokenizer here, right? And in this Lambda function, it's very simple. I'm just taking the question and context. This is what user will give. So in the previous example, we have seen the trigger was and HTTP, S3 upload. But here I'm going to use an API gateway. Okay, and we have not discussed API gateway, but I'll show you. But basically, it's an endpoint. Okay, which AWS API gateway service is a managed service where you can just create your APIs there, and you can define your methods like post, put, whatever it is. So it will come from API gateway, and that will contain, so the body of that request will contain something called question and something called context. So we are going to read that, and then in this 4 lines, okay, it will convert that text into a token. I mean, it will first tokenize that. It will convert that into a string of numbers, and based on the model that we are selected, right? So here we are using a pre-trained model for question and answer, right? And it will predict the answer at the end, right? And then you will get a response of the question and the answer. That's all. Okay. So you can go over this code. I mean, this is not a very difficult code to understand, but the idea is not about this code. Okay, so it can be anything of your choice, but the idea is how we are loading our models locally within our Lambda function, and calling using that model for inference. Okay, so one last thing before I show you the end result is the SAM template. Okay, so this is the SAM template that we have, and if you look at it here, we are writing simple YAML format, and it will build the infrastructure for us, right? So the way that it works is it contains majorly 3 sections. One is description, another is global, and resources. Okay, output you can just ignore. Output is nothing but after deployment, it will just print the things that it has created. Okay, so description is plain English. It will just you can give whatever text you want. It is just like a documentation of your application. And the first 2 lines, I missed to tell you this. So SAM is actually built on top of something called CloudFormation, which is our infrastructure as a code service, and SAM is specifically for serverless and few other things. So at the end of the day, AWS will convert a SAM template into a CloudFormation template. Okay, and these 2 lines actually tell AWS to do that. It tells AWS that hey, I am a SAM template. Okay, so I know that there is nothing called SAM in your dictionary. So please convert me into a CloudFormation template. Okay, so that's what it does. And then comes the resource. Global, I will come in a moment. But in the resource part, we can define a function, right? So in this case, you can define any name. Okay, it can be hello world or whatever. And then you can define what type of resource that you want to create. So you want to create a Lambda function. So that's why it is AWS serverless function. And then you give some properties. So in the property, you say that this Lambda function is going to be an image type. So this is what this image container type is, right? If it was from scratch or a blueprint or anything, then we could have we could have not used this package type as image, right? In that case, it would have been code. right? So the moment you do this image, then SAM will expect the container details. So, and that is what is mentioned here, right? Where is the Docker file, which location, and what is the tag? Okay, and the last thing is this one. Okay, this is the interesting part. So in this Lambda function, the trigger is not S3, right? So this trigger is an API gateway, but I'm not creating an API gateway separately. Just like in Lambda function I'm creating here, I should have created an API gateway separate in this line maybe, right? But this is the beauty of SAM. You don't have to explicitly create a API gateway. You can mention that this Lambda function will have a trigger for API gateway, okay, and it will automatically create an API for us. Okay, all you have to say is what should be the path and what type of method that API gateway you want it to be. It can be post, get, put, whatever it is. Okay, and it will automatically create an API gateway for us. So once this is done, right, an output is just an output of all the resources that it creates, right? So this is completely optional. I don't want to confuse you with this, but if you're new to SAM, okay, if you already know about SAM, then you know what I'm talking about. And the last thing is global. So global is just like in programming, we also have some global variables, right, which can be shared across the whole code or functions. So here we are putting, we can put some common things. In this case, it may not make much sense because I have only one function, Lambda function called hello world. But in case you have hello world 1, hello world 2, and so on and so forth, and for all the functions, you want to have set some parameter, like let's say the memory size is, let's say, 5 MB. Okay, or maybe timeout is 300 seconds for all the Lambda functions. So you don't have to mention all of this separately in the property like this. Okay, you don't have to mention it like this. Okay, you don't have to mention it like this. You can put it in the global section, and it will be cascaded in all the functions that you create throughout the code. Okay, so that's about the SAM template. So we discussed three things. One is the SAM template, one is the application code, which is the Lambda function, and the Docker file, right, which will create this container. All right. So once this is done, what you can do is you can go to this folder. Okay, and inside that you can go to PyTorch local, and you can just say SAM build first. I'm not going to run that because it might take some time, and then you have to do SAM deploy. When you do the first time, you have to use guided option because it will ask you a few interactive questions. But for now, you can just say, but once that first time is over, you can just run SAM deploy, because whatever input that you give, it will be saved in a file called SAM config. Okay, like this. So it will ask you a lot of questions, and it all saves, when you enter that for the first time. So when you run it for the first time, you have to run it like SAM deploy -- guided. Okay, so once this is done, you will see that the Lambda function is already deployed. Okay, and you will get an API gateway, and I'm going to show you that because I've already deployed this. This is the PyTorch app local. If I click on this, you will see that it has an API gateway attached to this, right? And here you will not find the code, right? Because here it is image, right? In the previous example, it was code, right? The reason is because we are using a Docker container, so you cannot view this here. So if you come to click on this API gateway, you will find this API gateway details. And if you now click on this, you can either test it from UI, or you can copy this and paste it in, let's say, Postman, right? So let's use Postman. Okay, I'm just pasting it here. And in the body, I'm giving some question. Let's say, when was this car invented, and some text or the context, and let's send this. So now what is happening is it is going to hit that API, right? This is the API, and that API will trigger this Lambda function, and that Lambda function will do the inference. So while this is happening, this Lambda function will be triggered, right? So this Lambda function will be triggered, and it will contain all the event details. So in my case, the event details is this question and answer, which we have just given, right? In this case, this question and answer. And it will just read the question and it will read the context like this, right? And it will use this pre-trained model, which is, I guess, what model we have used. It's a Distilbert based model, which is basically based on understanding of dark information. I think you can read about it if you are interested in BERT, but basically it is going to use all these model artifacts and it is going to predict the answer, right? And in this case you see that it has predicted correctly. So now if I take another question, I guess I have another sample question. So let's copy this and let's try to paste it and send it, and you can see that it is able to predict the answer. Right now, with this, I want to stop here. But one last thing is I want to share with you is, in this case, if you see in this Docker file, I have added all these 4 files locally, right? So let's say tomorrow, if you come up with a new version of model, you have to update this, and again you have to deploy it, right? So one way to mitigate that is to use some shared file system, right? So that's why I was talking about EFS, which is a shared file system, where you can just mount that file system anywhere and you can dump that data, right? So I want you to explore this if your time permits, and if you're interested to know that that in this case you will not be using this local copying of data. Okay, so you are going to use EFS, and EFS will be attached. That file system will be attached to this Lambda function. Okay, so in that case, what will happen is you don't have to redeploy when you come up with a new Lambda function. New version of model. Right, so you can always always dump the new model in that shared storage, and it will automatically take the model artifacts from that shared storage. Right, so you are basically isolating your container, your Lambda function with your model artifacts. Right, in this case, your Lambda function contains the model artifacts. Right, so that is what is there in this GitHub repo. Okay, so you can explore this. So these two are exactly same. It's just that here it is using local storage and here it is using EFS. So with that, I've come to an end. So feel free to I'll just stop sharing my screen. If you have any questions or comments, feel free to reach out to me. I have you can ping me on LinkedIn. I will try to respond. And I guess we got a lot of questions. Okay, so yeah.
So yeah, this was a pretty interesting session. Yeah, there are questions, and they are liking your session.
Yeah,
but
sure.
We are out of time today, so feel free to reach out to Suman.
Yeah, so firstly, thank you so much, and we do not have much time, and in fact, I would have extend this for next 30 minutes, but I have a hard stop today at 7. But I'll just I want you to go over this GitHub link. I have sent it. Maybe Karthik can post it, but I will answer all of this. I think Vivek, you're asking about learn more about SAM. So I'll share the deck that I have. And Naveen, you are asking about BERT. I guess if Karthik is fine, we can have another session on BERT and transformer. I'll share about that. But in brief, BERT is a transformer-based model or architecture, which is used for NLP-based tasks, and it is amazing. Okay, I would love to have a session on that maybe in the next month, whenever time permits. And yeah, I guess these are the two questions. And Vivek and Naveen, I'll just do me a favor, just ping me in LinkedIn, and I will share all the resources, and I'll see you in the next meetup maybe.
Sure. Thank you, Suman. Thank you, everyone who joined in today.
Thank you. Thank you so much.
Thanks, everyone.